Ito tayo comparators. Actually, may second part to yung bounding and Schmidt trigger. But itong kalahati mo na yung di-discuss ko. Okay? So, can you see the PowerPoint?
Yes, ma'am.
Okay. Ayan. So, comparators, so we have two types. So, inverting versus non-inverting, zero level versus non-zero levels, Schmidt trigger and bounding. So, Schmidt trigger and bounding, so next topic natin yan. So, we'll concentrate on inverting versus non-inverting and zero level versus non-zero level. So comparators is used to determine when an input voltage exceeds a certain level. So parang on and off lang yung comparators, no? Yan, on and off switch, but using op-amp. Okay, so example here. Okay, so this is zero level detection. So as you can see, you have your, let's say you have a sinusoid input connected to the positive. Okay, and then your negative is connected to the ground. So ibig sabihin, your reference is at 0. Okay, so such that, so you have this one. This is a sinusoidal input. Okay, so whenever it crosses the 0 reference, so this is your 0 reference, the thick blue line. Okay, so whenever it crosses the 0 reference, 0 volts. Okay, so that's when it changes it changes output. Okay, so non-inverting, because if you have positive input, your output is also positive, but the output, you only have two levels for output: negative V out max and positive V out max. Okay, so it's either you have a negative output voltage saturation or positive output voltage saturation. Okay, so usually around equal to the supply. So in short, so if you have positive output, you have positive input, you have positive output. So your output is square wave kasi it's like a switch. It's either on or off. Okay? So if you have negative input, so you have negative output also. So in a way, this comparator also it seems like it converts sinusoid to a square wave. Okay, whereas in ano yung last week, integrator differentiator, so in a way it converts square wave to ramp or triangular wave, or vice versa, triangular wave to square wave. Okay, so ito yun, zero level detection on inverting. Question? Clear? Okay. Then next we have, okay, next we have, okay, okay. Next we have inverting. So still zero level detection. So when you say zero level, so the reference voltage is connected to the ground. Okay. So this time your sinusoid, okay, input voltage is connected to the inverting input. Okay, so you have the, again, input voltage connected to the negative input, and your positive is connected to the ground. So that means that your reference voltage is 0, such that whenever sinusoid crosses the 0 level, such as this point, okay, that's when you'll have an output, but inverted output, such that if you have a positive input like this, so you'll have negative output, okay, which is equal to negative V out max. If you have negative input, okay, wait. If you have negative input, you'll have positive output, okay? So, and you have an inverted output. So whenever you have a positive input, you have negative output. Negative input, positive output. Still square wave. So your output varies from negative to positive V out maximum. Okay? Approximately around equal to the supply. Yan. So with comparator, it's like you're just drawing the V out here. Okay, you have very minimal computation. Okay. So with non-zero level detection, so your reference voltage is no longer equal to zero. Okay. So since your reference voltage is simply not connected to the ground. So we have three types of non-zero level detection. First of which is using battery. So as you can see here, we have a positive reference voltage. So that means our reference is above zero level. Okay, so let's say somewhere here. Okay, so with positive Vref, so whenever your input voltage crosses the reference voltage, that's when you'll change there will be changes in output voltage. Okay, so since the input, okay, so V in is connected to the positive, so this is a non-inverting. Okay, so when you say non-inverting, so whenever you have a positive input, you'll also have positive output. Okay, but the changes in change in output voltage waveform happens during every time the Vin crosses the Vref. Okay, so let's say at this point, that's when V out changes to positive. Then it stays positive up until here. So when the input voltage crosses this Vref again, so the voltage output changes from positive V out to negative V out. And it stays that way until the next Vref. Okay. So until this point, okay? So when it reaches this point, so that's when the changes in output voltage occurs. So from positive V out again, so it will toggle to negative V out, okay? And it will stay at negative V out up until the next VRF, okay? Okay. Next is, what happened here? Okay. Okay, next we have question. Question, class. Is it
None, ma'am.
clear?
Yes po.
And so far? Are you sure? Okay. Okay. So the second, for non-zero level detection, again, when we say non-zero level detection, you have your Vref other than zero. So you have a Vref. So your Vref can be either positive or negative voltage. Okay. So second non-zero level detection is using series resistors. So we have series resistors R1, R2. Then it has a supplied by positive voltage here, but it could also be negative voltage, class. Okay. So since R1 and R2 are how are they connected with respect to the positive voltage, class? How is R1, R2 connected with respect to positive voltage here? Class?
Series, ma'am.
Okay, so series. Okay, so we have series. Okay, so R1, R2 are connected in series. But then take note that the negative voltage here is tapped at R2. Okay, so therefore the voltage across R2 can be determined either we can use voltage divider principle. Okay, so we have the voltage divider here. So Vref is equal to R2 over R1 plus R2 times the positive voltage. Okay, so let's say that the value of the Vref is this one. Okay, so you have positive voltage. So again, our input voltage is connected at the non-inverting. So that means that if you have positive input, you'll have positive input you'll have positive output, but changes occurs at Vref, okay, at reference voltage. So every time the sinusoid sine wave crosses the reference voltage, so that's when the output voltage occurs, okay. So you'll have just like this one, okay. So positive voltage, you'll have positive output when you cross Vref and stays that way up until here. Okay. Once again, if the input voltage crosses the reference voltage, okay, so you'll have negative output from here up until here. Okay. And then as it crosses again positive reference voltage, so it will again switch back to positive V out max. Okay. Okay. So clear? So meaning, so in this topic, so all you have to do is to familiarize yourself with the doodling of V out, okay, in reference to Vref. So you just have to familiarize yourself with the waveforms, okay, expected output waveforms. Okay, next we have, what's this? Okay, so another variation. So let's say you have an inverting, but this time using series resistor. So you have your um, input voltage connected at a negative, but this time the series resistors arrangements are connected at positive input. Okay. Okay. So uh, this circuit is an inverting non-zero level detection. So still the Vref is positive, okay, because you have positive voltage here, okay. But again, the Vref may also be negative if you have negative voltage here connected at R1. Okay, just like the previous slides, okay. So the positive input is connected across R2 such that your Vref is equal to R2 over R1 plus R2 times positive voltage, okay. So you have your Vref here, okay. So since this is an inverting, so every time your input voltage crosses the negative, every time your input voltage crosses the Vref, so if you have this input, okay, positive input, this part of positive input, you'll have a negative output. And then if the input voltage crosses this reference, okay, reference point Vref, so it will switch back from negative to positive and it will stay positive up until the next Vref, okay. If it crosses again the reference voltage, okay, so it will switch back to negative, okay, and negative until from here up until here it stays negative, so that's when it will toggle back to positive, okay. Saan ba applications ng mga comparators? So it can be used as a, uh, let's say, level control. Okay, so you may use this, okay, on and off, okay, toggle. Okay, wherein you may control the solenoid valves that controls the flow of water. Okay. Okay, so third is non-inverting using Zener diode. Okay, so this is Zener diode. You remember your Zener diode from LX1 class? Do you still remember your Zener diode? Anyone who remembers the Zener diode? Okay, so how does the Zener diode works? How does the Zener diode works? So, okay. Sige, please.
Kinakontrol yung current, ma'am, kung forward.
Okay, that's what the diode generally does. Okay, so diode generally does controlling the flow of current, but being a diode, of course. But what is specific is the application of Zener diode.
Voltage regulator.
Yes, voltage regulators. Okay, so the Zener voltage, okay, is can be used both in forward and reverse bias. By the way, what is forward bias, class? What is forward bias? When you say forward bias for diode, so what does it mean? As a review, when you say forward bias, so let's have a quick review here. Okay, diodes consist of positive and negative. So this side is positive, negative, right? So when we say forward bias, so what does it mean? What does bias means? Generally means bias in electronics, basic electronics. What does it mean when you say bias? Oh, you have to take note of those simple questions. It may be asked during interview while you'll be applying for SIT. Okay, so sometimes the questions are not that hard. Actually, the questions during interview, technical interview, are just basic questions. Okay, so that's why you have to don't never forget the basic subjects. Okay, so what is bias in electronics? So when you say bias, application of, anyone who remembers? Let me see. Okay. Thank you, Rosas. Putting a voltage across a diode. Okay. What voltage? So we have two types of voltage. Okay, or we have two types of supply. Uh, DC and AC. We may have two types of supply, AC or DC. So when say bias, what does it mean? Application of AC or application of DC? Okay, thank you, Richard. Okay, so when you say bias, so generally application of DC voltage. Okay, application of DC voltage. So it sets the level. Okay, generally bias sets the level or turning on the diodes. Okay, so basically it turns on the diode, then when you say also biasing technique, so it means setting of the reference voltage or level voltage. Okay, then okay, so that is for bias. So we have two types of bias. We have forward bias and reverse bias. So what does forward bias means? So forward bias connecting. So where do you connect the anode and cathode? Anode is connected to and cathode connected to. Okay, so when you say forward bias, review. Okay, forward bias is connections of anode to So we have the DC has two polarity, positive, negative. So what you connect to the positive side of DC and negative side of DC? Which is which? Okay. Uh, how do you pair up to have a forward bias? How do you pair up? So you connect the anode to? You forgot? LX1. Going back to LX1. You forgot? How do you light up LED? How do you light up LED? Okay, thank you, Carlos. So, forward bias, anode to positive, and of course, cathode to negative. Okay, positive to positive and negative to negative. Okay. And of course, likewise, so when say reverse bias, So, anode to negative, okay, and cathode to positive, okay. Okay, thank you. So that's what ordinary diode do, okay. But Zener is a special diode, okay, in which it can act, it can be used both as forward and reverse bias. But of course, if you're going to use Zener diode, so it is basically used in forward or reverse bias. So
Reverse.
that, okay, reverse bias. Okay, thank you. So Zener diode is basically used in reverse bias. Okay, but so kanina may nag-answer, no. Diode is generally used to control the flow of current. So that's what the diode do, no. Yan, parang dinidisiplina niya saan dadaan yung current. Okay. So para siyang traffic enforcer, no? O, dito lang dadaan dapat yung current. Okay? Bawal sumalubong, no counterflow. Okay, so that's what it do. But for Zener diode, so Zener diode is a special type of diode, so wherein it can be used both in forward and reverse bias. So in this slide, okay, can you see the slide? So what is the configuration of this Zener diode? How is it connected? Is it connected in forward or in reverse bias? What do you think?
Forward.
Forward.
How can you say it's
Forward.
forward?
Yung sa, ano mo, sa line.
Okay, can you see my pointer? Can you see my pointer?
Yes, ma'am.
Okay. So this side, okay, what is this? Anode, cathode. Come on, it's better to be wrong
Cathode.
now than to be on the interview.
Cathode.
Pag ini-interview kayo dun, mali-mali kayo, di ba? Mas nakakahiya yun. Kaya dapat ngayon, mga correct na yung mga misconceptions nyo. Okay, this side is cathode and this side is anode. Okay. Again, so when we say cathode, that's positive or negative? Cathode.
Negative.
Negative.
Okay, negative. Okay. Cathode is negative and it is connected at? What's this?
Ground.
Ground.
Positive voltage.
Positive.
Ay,
Positive
Positive
voltage. This is the ground. Okay. Okay. This is the ground. This is simple for ground class. Okay.
hindi ko na nakita, sorry.
Okay. You made me smile. Okay, cathode connected to the positive voltage and the anode is connected to the ground. So therefore, the configuration of this Zener is forward or reverse bias.
Reverse.
Okay,
Reverse.
so it is connected in reverse bias. So if the Zener diode is connected in reverse bias, so the voltage across what's this? The voltage across Zener would be equal to Vz. So it has a Zener voltage. Okay, so okay, Zener voltage wherein the cathode side becomes negative, positive rather. So the cathode side become positive and negative. So ganun ang nangyayari dyan. Ano? You have parang reverse voltage. Okay? Okay. You have, okay. Again, if Zener is connected in reverse bias, so it exhibits a Zener voltage. Yan, wherein the cathode side becomes positive and the anode side becomes negative. But of course, if the Zener diode is connected in forward bias configuration, so it's like an ordinary diode, wherein the voltage across diode is equal to What is the voltage across diode? Ordinary diode, rectifier diode, equal to
0.07.
0.7. Okay? So if it is again in forward bias, voltage across Zener is 0.7. But if Zener diode is connected in reverse bias mode, so it exhibits a Zener voltage, okay, wherein the cathode becomes positive, again, anode becomes negative. Okay, so therefore, if that is so, okay, so your Vref is actually equal to Vz. So you have your Vref here equal to Vz. Okay, so this is a non-inverting. Why? Because you have your input voltage here connected at a non-inverting input. Okay, and this is also a positive VREF because the Zener diode is connected in reverse bias, so it exhibits a voltage equal to positive VZ. Okay, so again, so every time your input voltage here, so you have a sinusoid here, every time it crosses the reference voltage, which is equal to Zener voltage. So if you, this part would have a positive output, while from this part, okay, from this point to this point, so you'll have negative output. So in comparator, so all you have to do again is to familiarize yourself with the waveform. So how it will behave. Okay. Yan. Sasauluhin nyo lang yan. Okay? And last, okay. So last na yon. And lastly, we have inverting using Zener diode. Okay. So we have here positive, you have your input at positive and inverting. Teka lang. Ito yung kanina, di ba? Yan, baliktad. Okay. Okay, so inverting, wherein your input voltage is connected at negative and the reference voltage is connected at positive. Okay, so again, so we have the VZ here or the Zener diode in reverse bias, okay, connected in reverse bias, such that your Vref is equal to VZ. Okay, then therefore we have every time you have an input voltage here, okay, as every time it crosses the reference voltage, so it changes from, okay, from this point to this point, so it will become negative, okay, but from this point to this point, it will become positive, okay, and then negative again for this time, okay. So in short, so comparator changes the waveform from sinusoid to square wave, okay? So when it will occur, so it depends whether it is zero or non-zero and whether it is inverting and non-inverting, okay? So any question? That's all for this morning. Okay, I haven't finished the bounding and Schmidt trigger, so I'll notify you when it's done or, okay. Any question about this one? So for the seat work, so I'll reserve it later. Hindi ko pa nagagawa. Question, class? Nabitin ba? Oo, 19 na tayo nadagdagan. Okay, so I'll download the attendance list. Okay. Question?
None.
None. Is it clear? Next week.
Yes.
Okay. After the pounding and Schmidt trigger, okay lang ba na after kung magawa yung what do you call this? PowerPoint? I-upload ko lang sa YouTube? Or you prefer it na may lecture?
May lectures. Oh.
Okay, lecture. Okay, so after I prepare the bounding and Schmidt trigger, that's when we'll have our second unit exam. So second unit exam is from haba-haba, no? Yung mula differential amplifiers, integrator, differentiator up until the Schmidt trigger. Okay, one last lecture and then we'll have our second unit exam.
Mama-upload din po itong lecture na to sa YouTube.
I-update ko. Actually, it's already uploaded.
Sige po. Thank you.
Uploaded na ba? I believe so. Kung hindi ko siya na-upload, nakalimutan ko to. Let me see.
Okay.
Tagal nung net. Okay. Hindi ko siya na-upload. Okay, I'll upload this PowerPoint. Okay. And then if after ko magawa yung quiz, then I'll notify you, if you have quiz to answer. Okay? Any question, class?
Magpa-download po din yung nakarang lesson, no? Hindi nyo na-download.
Nakaraang lesson, di ko rin nalagay.
Opo.
Talaga?
Meron po.
Meron, ma'am. Meron.
Theory talaga.
Easy lang eh. Wala yung file.
Integrator and differentiator, di ba? Ito.
Yes, ma'am.
Oh.
Sa YouTube, ma'am, pinost.
Tsaka hindi. Dito sa MS Teams, merong PowerPoint.
Sa general.
Tama ba?
Sorry.
Ano ba lecture natin nakaraan? Integrator and differentiator. So, I have it here. PowerPoint. Meron
Yes,
din sa
ma'am.
YouTube. Okay. Ang dami na nating coverage ng unit exam number 2. So, you have differential instrumentation amplifier, integrator, differentiator. Then you have comparators and bounding and Schmidt triggers. So, you have mahaba to. Ang galing naman kayo, di ba? Okay. So, any question?
Wala na po.
Okay.
Thank you.
So, see you again.
Thank you, ma'am.
Okay, I'll update I'll do the quiz and then I'll update you. Okay, stay safe, everyone. Okay. Thank you
Thank
for
you.
attending my class. Okay. Bye.